Let's look at another example where our goal is to set up an integral that gives us the arc length of the hyperbola xy equals 1 from the point 1, 1 to the point 2, 1/2, and using an approximation technique to then evaluate the integral. So let's first start by noticing here that we need to write y equals 1 over x, and then we get our derivative. When I take the derivative of x to the negative 1, we would get negative 1 over x squared. So the arc length will be the integral. Now notice I've written y as a function of x, so we're going to integrate with respect to the x coordinates. So 2 to 1, or excuse me, 1 to 2, square root 1 plus our y prime here was negative 1 over x squared, squared. Simplifying this, I have 1 plus 1 over x to the 4th. And now our goal is to then use an approximation technique to evaluate the integral. And one approximation technique that might be useful here would be Simpson's rule or trapezoidal rule or midpoint rule, one of those approximation methods that we've learned in chapter 7. I know that Simpson's rule, for instance, is going to give us the most accurate approximation. So let's do Simpson's rule with n equals 4 subintervals. So we'll do S4. To remind you of the formula, it'll be delta x over 3, f of x0, 4 times f of x1, 2 times f of x2, 4 times f of x3, and then f of x4. So here our delta x will be 2 minus 1 over 4, so 1/4. And so it'll be 1/4 over 3, so 1 over 12. F of x0 will be 1 as our left endpoint. So it'll be the square root of 1 plus 1 over 1 to the 4th, so square root of 2. And then the next one will have 4 times f of x1. Notice f of x1 here will be 1.25 for x1, 1.5 for x2, 1.75 for x3, and then 2 for x4. Okay, so just getting those grid points in between. So we'll have 1 plus 1 over 1.25 to the 4th, 2 times the square root of 1 plus 1 over 1.5 to the 4th, 4 times the square root of 1 plus 1 over 1.75 to the 4th, and then finally the square root of 1 plus 1 over 2 to the 4th. Oops. Now let's evaluate this in a calculator. Evaluating in a calculator, I get something around 1.13254.